afternoon, and thank you for the introduction. And on behalf of our group, it's a real pleasure to be here today. I'm going to talk about Benthic Fauna with a specific focus on what they do, their functions, and I'm bold enough to propose this as a modest advancement on current tools for ecosystem assessments, and you can boo me out at the end if you disagree with me. So what I'm going to talk about, just give you a bit of a background and the approaches we're using and why we're using them. I'll give you two case studies from the Barents Sea. One of them across a polar front transect, across the Spitsbergen bank, and the other one using the offshore petroleum operations area in the southern Barents Sea in the Norwegian sector. I'll talk a bit about the implications of this and try and make some conclusions. So, background. Most of you in this room are familiar with sampling benthic fauna with a Van Veen grab or other kinds of grab or box corers. The infauna is the small animals living on or in the soft sediments or soft-ish sediments. Traditionally, we count them, and we identify them first, and then we count them, and we're using this as a tool for environmental assessment. Anybody not familiar with this can contact me. I don't want to go into that in detail, but it's being used. We can use spatial and temporal information out of this. There are a number of strengths and weaknesses, and as Eddie Carmack said yesterday, I should actually write challenges rather than weaknesses. Benthic fauna are sensitive to ongoing changes. They're sensitive, they react to their environment in a predictable and well-researched manner. So we'll give that's a strength. They're integrators of short-term fluctuations. The community structure doesn't change on a daily basis, so a single sampling event can represent a reasonable length of time. The challenges are this is time-consuming. We need a lot of specific experts, and there aren't enough experts in the world to supply what we actually need. So this is a challenge. And we need a high level of quality assurance or standardization in sampling and sample processing for the data to be meaningful. And I'm going to talk a bit further about that in connection with the needs for ecosystem scale information. Because we're moving now from local surveys to needs for large-scale and long-term assessments, and this has a particular set of challenges. We need to know not only the patterns, but what they mean. So, we're identifying animals on the basis of their anatomy, their appendages, but in an ecosystem perspective, what's really important is what the animals are doing with those appendages. So, I'd like to propose a simple approach to faunal functions. We have chosen 4 main categories, which we think are important and widely known information about animals. First of all, what things eat, how do they eat them, do they move, what extent do they move, and to what extent are they moving the sediments around? To what extent are they digging and transporting particles? Of course, there are very many functions that we should be taking into account, such as reproductive strategies, longevity, size, but we just simply don't know enough information, and we're working with more than 1,000 taxa from the Barents Sea. We simply don't have all that information. So I call this a lowest common denominator approach. What I'll do is I'll just skip very briefly through the principles of our approach without going into details. What we end up with is a list of taxa that we've found here, and our 4 basic categories, and we code them with a binary approach, which is inspired by phylogenetic analyses using cladistics. It's very simple. It either does it or it doesn't. Some animals do many things, and that's simple. You just give it a score for whatever it does. It can do 2 or 3 things. It can do all of the above. It's not a problem. Then we've made a set of categories, functional groups, which are recently recognised in the literature, but we've made a kind of database code for gathering this information in a repeatable manner and quite transparent. For example, motile filter feeders, sessile filter feeders. And this is nothing new. It's based on about a century of research. This is only a few of them. So, to the first case study, the polar front transect. Here's Norway, the Barents Sea, and here's the black dots representing a number of stations. The grey line is the average position for polar front. So we're spanning trough conditions to bank conditions, slope, and another trough and a slope, and some various conditions there. This is a work that's under review for Journal Marine Systems at the moment. So using traditional taxonomic names, what you're looking at here is a correspondence analysis. The blue numbers here, these are stations, and generally the closer together these stations are, the more similar they are, and the wider apart, dissimilar. The red names, these are taxa that are characteristic of stations. So quite simply here, we've got, these are the bank stations, these probably west-southwest of this figure is the deeper stations, and we've got some taxa here characteristic of rocky, stony, gravelly areas. Quite logical. What's interesting though is that these are dividing into geographic areas. We've got the bank, north of the bank, and south of the bank. However, using the same data set, using functional group information, I'm going to zoom in on this figure in a minute. But what you're looking at is the same kind of correspondence analysis here, and we've got the bank stations here with a set of characteristic functions: mobile, motile, filter feeders, and carnivores, and then we've got some distinctive functions on the depressions, the deeper areas, and these are bioturbators, deposit feeders, digging animals. This station up here is pulled up there because of an enormous quantity of organic polychaetes. So the take-home message there is that here we're getting a division into bank, slope, and depression. Here's just a pretty picture of a typical depression conditions. You can see the upper loose layer, there's a lot of bioturbation going on in there on top of the older glacial marine sediments. And here is from the top of the Spitsbergen bank, a lot of stony stones, boulders, and what's interesting is our functional analysis showed very little digging, and here you see evidence of that, the activity, the action is all at the surface, and around here you've even got some tendency towards anoxic conditions. It fits very well anyway. So the implications of this is taxonomic names are giving you biogeographic information. It will tell you something about water masses, water characteristics, and what have you. Functional groups will give you a quantitative approach to ecological information, such as the sedimentary niches, if you like, and something about sediment functioning, what's going on in the sediment, biological mixing capacity, and particle processing dynamics. Okay, so far? Then we'll move to the next case study, which is the offshore operations area. This is data from the Norwegian national database near here, Overvåkingsdatabase. This is belonging to the Petroleum Producers Association. All the offshore surveys on the Norwegian shelf are put into this database. There are hundreds and hundreds of stations. There's annual sampling, and each area is sampled at 3-year intervals. This is a big resource. However, I said I was going to talk about data standardization in terms of monitoring and assessment. And it always makes me feel like hanging out my laundry in public, which we're kind of conditioned not to do. But I'm going to do it anyway. This is after homogenizing between 15 and 20% of the taxonomic names in this database. We've standardized how they are recorded. Even after that, this is the trends here. The purple dots are one consultancy company who've produced this data, and the green dots are another. I've used the last sampling event, the last time that a particular field was visited. Each dot represents a field of maybe between 8 and 50 stations, and each station is 5 sample replicates. So this is a lot of data. Just tried to simplify it for this presentation. However, to me, I don't know how to interpret this. The Norwegian authorities are at me to produce a report on this and to interpret this, and I keep saying, I don't know how to get ecological information out of this. Because these arrows here, the stations beginning with S, this is from the Snøhvit field, these are very close, these are neighbouring, and they're way on the other end of the diagram. There is no relationship with water depth or sediment types or anything. I don't know how to interpret this. So the only thing I can think of to do is to rerun this using functional groups. And what happens here is we're getting a completely different picture. The functions are in the middle, meaning there's no particular area that has particularly characteristic functions. That's not surprising because it's quite very highly diverse, quite homogeneous sediments, and pretty much all the functions are represented at all the stations. What's interesting to me is here we've got all the Snøhvit ones together, and the purple dots are actually aligned with the green dots. This makes sense, and the deeper areas are coming together. The fact that the deeper areas are green dots is just precisely because the two companies sampled different areas. So, we've removed the institute bias, because even if things are called different names, they've still got the same function. And we've got a better spread of stations according to sediment composition, and also depth is reflected in there. So this to me makes a lot more sense, and I'm able to start talking about something meaningful here. This is a work in progress. Here I've taken those stations or fields which have been sampled once or more than once, so 2 or up to 5 times. And again, I don't know what to do with this, because again we've got the purple dots from consultant A on one side and consultant B on the other. More than 40% of the variance in this data set is explained by which company produced the data. There probably are some real changes in there, temporal changes, because there's low abundances and high diversity. So it's very small fluctuations in dominant taxa are going to make have quite an impact on the results. But this is to me masked by the name problem. So we were hoping to show you the next step, the functional analysis, but we weren't able to do it, so it's a case of watch this space. So I'd like to make some conclusions, and the obvious one is we need identifier workshops. We need to exchange literatures between identifiers, blah, blah, blah. But this is an ongoing problem. We will never manage to do all of this for all data and for all purposes. We need tools now. So this certainly needs to be done, but we also need a quick and dirty approach. So in areas of physical heterogeneity, I would quite like to say I agree with Pooh Bear and my small son. Yes, please, I'll have both. I would like to see the use of names and functions. I'm not saying that you need the names in order to record the functions, so why not use both? And in fact, I'm so keen for people to do this. Once our approach is peer-reviewed, it's going to be laid out for open access, or at least online access. I would like people to use our database. I would like them to criticize it, expand it, and help us improve it, and we'll generally work together on this. For large-scale and long-term data sets, We get an indication of taxonomic composition and sediment function. We can use this for both spatial and temporal trends, and we get a rapid assessment of broad patterns in what I call multi-source data. So I'm quite excited about this. I'm looking forward to developing this a bit further. And for future study, I think looking at the relationships between functional composition in sediments, food sources, food quantity, quality, is going to be quite an interesting area for further work. So thank you very much.
Thank you for your presentation. I agree with you that we have a lot of data but no information for decision making. And my question, what first step we need for start analysis for decision makers?
That's a good question, because what we really need to know is, has there been a change, and if so, what level of importance? As long as we have habitat niches, we may assume we will have animals to fill them. And if one species is replaced by another one, which has the same function, we could probably say, or start to debate, is this of ecosystem importance or not? So I think definitely looking at the functional trends is going to be increasingly important in decision making of what's important. If suddenly all the bioturbators are disappearing, or we've got a shallower bioturbation, that says something about the function of the sediments in the ecosystem. Quantifying meaningful, ecologically meaningful change, I think, is a step to go.
Any other questions? Actually, I had one. You mentioned on the top of the bank, I think, you said that there was evidence of anoxic conditions, which surprised me to no end, because there's a tremendous amount of tidal mixing out there. How would you get anoxic conditions?
It's just, yeah.
Those conditions are such strong mixing.
I know exactly why you asked that. It's not anoxic as such at the surface. Sorry about the underwear there. Here, of course, at the surface, this is very consolidated, thick clay. If nothing is burying in it. So here, this is just simply, there isn't anything moving around here. So this compacted clay is so compact, it's not non-porous. It's really hard. This is...
so is that on top of the bank?
That's from the top of the bank. So it's actually an interesting situation where you've got gravels and pebbles on top of clay.
Yeah. Just one more question.
Yeah?
A very short question here. Do you know the functions of all the important, at least taxa, in spite of the missing taxonomy for the different collectors? Do you know the function? Do you know the functional groups here?
We don't know all the information, but our categories are so basic or fundamental that we can infer those ones. But of course, it's always going to be a work in progress, but for the most part, we've lowered and lowered our level of detail until we get to something that we can, with a reasonable amount of honesty, say, yes, we do know for all of them.
Okay, thank you very much.